before we talk about the object detection, let me say something about your team project, especially for your presentation. Okay, it should be 2 weeks, right, from now, right? Okay, I have my last lecture next week. Okay. Here's what I need you to prepare for your term project presentation, the slide, okay? The following must be included in your slide. First, the cover page, the title, all team members, okay? And the title must be very specific. Okay, don't just say segmentation or object detection. No, it got to be very specific. Okay, and then give the problem description. Okay, so give the overview of the problem statement and also your objective. Okay, of this project. At the meantime, you might show the audience about what will be the images look like, okay, for your task, okay, no matter for defect detection or for anything else, okay, just give some, not just verbal description for the problem, but also give some demonstrative image, okay, and finally, you must give very clear objective to achieve, okay. And then your proposed method, okay? Describe the algorithm. You are encouraged to include the flow diagram of the method, okay? It need follow a lot of some processing. For example, you need to do image smoothing first, then go for some traditional machine vision or deep learning, okay, anyway, okay? And any figures or images that were supposed, the proposed methods that might help the audience to understand what is the proposed method, okay? And the fourth part could be the most important part, which is the experimental result, okay? The first part is very important. You need to tell the audience where is the sources or how you prepare the data set for the experiment, okay? If the images are collected by yourself, you might talk about the hardware system as well, okay? What is the camera, what is the lighting, how you capture the image, okay? If the data set is based on the public library or provided by the manufacturer, for example, just say it, okay, then show some of the representative image, okay? Both for each class, if you are working on classification or for segmentation, okay, just give some representative image for the experiment. And also it is required, you need to tell the audience what's the number of the training sample, okay, for each object category, okay? If for example, if you have 3 classes to identify, then you have to show each class, okay, show the image for each class so the audience can understand what will be the problem and what would be the challenge or the problem, okay? And also you need to give the number of testing images, okay, for each object category, okay? And any additional information that might be required. Okay. So the first part talk about how the data are prepared or where you get the data. And lastly, then you can talk about, based on your proposed method, you talk about your test result. Okay, do some analysis. What will be the metrics? Okay, to evaluate. Okay, false positive, false negative, precision, accuracy. Okay, and also conversion metrics or any some statistical analysis. Then you need to don't just show. Okay, without any discussion, okay? And then the discussion of the experimental result. And also, just talk about the computation time, okay? For both training time, for your method, and the inference time, okay? And the inference time for the computation, so that the audience can evaluate the proposed possible to be realized online, real time or not. Okay, and also talk about the finding from the project and the finding from the experimental result. Okay, what could be the advantage, what could be the disadvantage, and what would be the restriction. Okay, for that. Okay, so that's it. Okay, then you give the summary and conclusion. Okay, so I didn't ask each team might have 15 minutes, okay, for the presentation and 5 minutes for Q&A. Not from me, but from the audience, which you can. 15. So prepare the slide for 15. But first, I put a note here, and also you might include the appendix by the end of the slide. The purpose for the appendix especially something to do with the figures or image, okay? Especially when you do when you're in the Q&A section, the audience might ask you questions, and which are very difficult to describe the verbally. Maybe in that case, you have a. So when you prepare the slide, you must think of what could be the problem that audience might ask. But you don't have enough time to talk about the details. 这个附录呢很重要我讲过他扮演的角色，就是你要想，你讲完以后，你下面的听众可能会问你什么问题，可是呢，你没有时间讲，因为你只有15分钟，所以你没有准备要讲，可是你一定要准备人家问你。那这些appendix一般来讲会跟图或表有关系，因为图表很难用口语的方式去描述。OK， but for the items 1, 2, and up to 5 must be must be in English. Okay, they must be in English. And you don't need to write the full sentence. Just give some, just this, a line or few lines. But never just show the table or figures without any description. 听好，投影片呢不准只有出现图或表，下面没有任何说明。Okay, because the purpose of slide 1 is for the audience, the other one is for the speaker. It will guide you what to share with the audience. 好，所以那个 slide 呢不准只有图表，没有任何说明。可是说明呢不用选句子。Okay, you just itemize what you want to share with the audience. 把它条列式就好。You know what I'm saying? I don't need a full sentence. Okay, but you need to write something. Okay, other than the figures and the tables. Okay, so for items 1, 2, 3, 4, 5 must be in English. But for appendix, which means there the additional detailed information or the experimental result can be written in Chinese. OK， 可以写中文，可以用中文，可以用中文，我允许你用中文写，而且要写，因为我 I try to make your life a little bit easier, which means, okay, I mentioned here, okay, the slide item 1 to 5 must be English. The appendix is up to you. It can be either Chinese or English. That'll be fine with me, okay? Because the last item I written here, no written report is required, okay? Which means I will evaluate based on your presentation and the slide, okay? So that's another reason I need you to say something in the appendix, okay? Which you may not present it, okay? In the slide, okay? So, but the appendix could be Chinese or English. Just give some more details information to help me to evaluate your performance, okay? Okay, and the other purpose is you prepare the appendix to answer the question for the audience after you do your oral presentation. Okay, so I put it here, no written report is required, which means you need to finish, okay, all the project work on January 16th, okay, which will be the final exam week, okay? We don't have a written exam, but you do your final presentation, okay? This will be the Tuesday. So when you come for the presentation, you need to print out, okay? You need to print out the slide to me, okay? So, and if you can do that, you don't have to turn in the written report after the presentation. 也就是报告结束完以后就结束了 ，OK？ 可是呢，你们的当天报告的投影片一定要印出来给我，含 appendix. Okay, here's the requirement: 2 slides per page and single-sided. You know what I'm saying? 一页好。This is A4, you just print out, okay? Slide 1, slide 2, but single-sided. Don't use double-sided, okay? 有点浪费纸了，可是万一有时候我老师要写一些评论或者是什么的话 ，okay? Okay, everyone, fine, okay? You need to print out, okay? If the figures or the image is colored, that if you can print out, the printout will be colored, that'll be fine. If not, black and white, I can accept it. Okay, I can accept it. Okay. And also, on the presentation day, you need to send your electronic file, okay, to CARS, okay. That's for IET. Okay. We must keep something in file. Okay. 那 IET 那个工程评鉴的那个啊，所以你的电子档同时要传给那个 CARS， 就是在那一天，好吧？好，所以意思是说呢，你那一天做完报告，因为本来就是要准备投影片嘛，做完以后呢，同时那一天就要印给我，报告前。就要印给我 ，OK？ I need the physical printout, OK? Just print out the slide, OK? And after that, everything is done, OK? You don't need to go back and write the report, OK? So just make your life a little bit easier, OK? And then you need to focus on assignment number 5 and the final term project, OK? OK? So any questions about the preparation of the slide here? Okay. You can find the description from the portal. Okay, should be no problem. Okay, but let me remind you one more time. Okay, the experimental result. You must talk about the detail, how you prepare the data. Okay, and what are the sample and the number of sample you prepare. Okay, for the experiment. And if you collect your own image, you need to talk about what is the hardware you use, and also talk about what will be the PC and GPU, especially when you analyze the computation time, okay, for training and for test. Okay, so that's all about your project. Any question? Yes.
我们的报告是在期末考那一周，对吗？
对啊，不是，
因为
不是16号。
我看原制的行事历上面写15号是寒假开始，然后期末考周好像是6号到12号，是吗？是。不是。
Oh, okay, maybe I'm wrong. And anyway, starting, I still have a last lecture next week, right? And after that, that will be the presentation day. So it will be 6, so not 16.
Not 16, it's 9. January 9.
I don't know where I come up the.
You can click on the right side in the bottom. It's where we.
No, that'll be fine. Just Tuesday. You know what I'm saying? Okay. Just enroll. Okay, it's not. Should be January 9th. Okay, January 9th. Okay, 好，这是1月9号，星期二。OK，应该是啊，因为我们2号。OK，we will have my last. You will have your last class on January 2nd, right?
Yes.
Okay, then yeah, it got to be 9, not 16. Okay, I hope. OK。好，这是再说一次哈，1月9号，好不好？那天做 presentation， 同时给我印出来的投影片，好不好？啊，你一组只要印一个 ，OK，one team, one print out, OK, that's good enough, OK, OK, and any further question? Okay, good, okay. Okay, now we can go back to talk about we are not finished with we are not finished with the object detection, right? Okay. Okay, about the about the regional CNN, we have a last model. Okay. Need to talk about, which is we already mentioned about ASEAN, fast ASEAN, faster ASEAN, right? The last ASEAN-based architecture model is okay, is Mask ASEAN. Okay, again, developed by or proposed by Hercules from Facebook. Okay, you might think of Mask ASEAN is faster ASEAN and plus semantic network. Okay, a mask for segmentation. Okay, segmentation by using. You know what FCN is, right? What is FCN? What?
FCN.
What? What's FCN? When we talk about semantic segmentation,
Fast
or
convolutional network.
40 convolutional network. Okay, right? 40 convolutional network. Then we talk about set network, right? Segmentation network. Then we talk about what UNet, which is your segment number 5. And we talk about the dense net, and then deep lab, right? Deep lab. Okay. So you still go for the very first easy one because it tried to make it fast, so you simply use FCN. Actually, you can replace this with UNet or DLAB. That'll be fine. Okay. Just look at what. First, you use the fast FCN to identify the bounding box. Then, from the bounding box, you try to mask the object by using any semantic segmentation network. But the classification, bounding box, and also semantic segmentation has been bundled together, okay, in the mask RCN, so which is also very famous one. Even you use a very simple FCN, the performance is still quite good. Okay, it's still quite good. Okay, so let's talk about how it works. So basically, you won't see too much difference here. Okay, the input, then you go for the base backbone. Okay, here because as I mentioned, because fast RCN was developed by Herkami, so the baseline is residual net. Okay. 因为 residual net 也是很肯定它开发的啊，所以 so the backbone is still then then extract the features and go for the region proposal. We still require the region proposal network. Okay, then find possible anyway. Then it further based on the feature. One is for classification, for regression, just like any CRM-based model. But right here, it has an additional branch. You can see the FCN here, just 40 connected layer. Okay, you will do the upsampling. Okay, just upsampling. Okay, and then find the corresponding mask. Okay, based on the identified bounding box. Okay, that's it. Okay, that's the additional work. Okay, let me say something about the detail. Because it doesn't use, remember when we talked about the fast RCN, it needs an anchor, right? Right? You need to find the anchor and then you try to come up with 9 anchor boxes, right? 3 scale and 3 aspect ratio, right? Okay, so that's 9. That's it. Okay. It's use different scale to evaluate the variation of the object. But in Herkami's mass RCN, it used the so-called feature pyramid network, okay, FPN, okay. Up to now, still a lot of model is based on the feature pyramid network, okay, especially it try to handle the scale variations, okay. So this simplify as FPN, okay. So here's how it goes, okay. Let me just talk about this feature. Okay, first it talked about the bottom-up pathway. Okay, the bottom-up pathway. Again, the backbone is residual net. Or actually, you can apply VGG. That'll be fine. Or even you can, if you want, you can use convolutional net. just like your assignment number 4. Okay, but in the original baseline model, okay, it still uses residual length. Now, every time the image or the feature map will be reduced by half, right? Okay, you downsampling with a stride of 2, okay, or downpulling with stride of 2. So the size will getting smaller and smaller. So this just show you if you go for 3 steps, okay, go for 3 steps. This is called the bottom up. So this is the input image. Then you go for 3 convolution, for example. Okay, actually it could be more than that, but anyway, you have a 3 major layer. Each time the size of the feature map will reduce by half, okay, or a factor of 2 with a stride of 2, okay. And then here is because it's from the original image and then bottom up, so that's why I call pyramid, okay. That's why I call pyramid. 为什么叫金字塔啊？因为它越来越小 ，okay, getting smaller. The feature, the input or the feature map getting smaller and smaller, so it looks like a pyramid, okay, 像金字塔 okay. And then this goes to the top down, okay. So then the feature map will be scaled up, will upsample with a factor of 2, okay, because each time it will be reduced, right, by the size of 2. Then it will increase by the size of 2. And then, based on the feature map here, then we can do the prediction. Predict of what? Predict the class and the bounding box. Okay? So you will do the prediction in each resolution here. Okay? That's how you handle the changes of the scale. Okay? Okay? Well, actually, you still need anchors. You still need anchors, but it doesn't need to try out different scale because scale has been handled by the bottom-up and top-down feature image here, which means you will identify the bounding box in each level. Okay? Now, and you can see here, it also make the skip connection, okay? The skip connection, or you call lateral connection, okay? Lateral. A little bit just like a unit, right? A little bit, but it's different, okay? This is nothing to do with encoding, decoding, no. It's just button up, then top down, okay? And here, okay, how you do the lateral connection is like this, okay? For each connection here is upscale, okay, with a factor of 2, okay? And then this one is from the corresponding layer in the bottom-up pathway, okay? But before it do the lateral connection, it go for a 1-by-1 convolution. You know what is the purpose for 1-by-1? What is the purpose? 为什么要一乘一？唯一的目的是什么？ To reduce the channel, right? Reduce the number of channel, the depth of the feature map. Okay, that's the only reason for that. Okay. Now you can do the lateral connection, which means the input will have the same size as the size after you upscale by 2. Okay, they have the same size. Then you put a plus here, then it means the lateral connection is carried out by pixel-wise addition. Well, actually, some people might use concatenation, but in Herkimer's math Gaussian, you use element-wise. Okay, addition. Okay, 也就是说，它为什么叫 element 不叫 pixel？ 是因为我们谈的都是 feature map， 所以它是点对点的，把它相加在一起。Okay, they add them together. Okay, they add them together. Okay, additional ones add. Okay, So it will be the same for each level here. Okay. So actually after that, it still will go for at least one convolution, a 3x3 convolution, and then you do the prediction. Okay. Predict the class and predict the bounding box. Okay. So so this is the so-called feature pyramid network. Okay. So you will. So what is the prediction right here for this feature map here? It tries to predict a large object. What is the prediction here? In this level, which is corresponding to the original input image, it tries to predict a very small object. Right? When the image is getting smaller and smaller, and the very small target object will be gone, right? You cannot find it. But the large object will be preserved, okay, in the higher level of the pyramid. 所以呢，上面的这一个呢，是用来这一个是用来侦测大物体，也不要说小是因为它小，大物体呢在这里还会出现。这个呢是用来侦测呢小物体。Okay, so let me say it again. Okay, top down, the top feature map here, or it tries to predict a large object. Okay, but for the lower level in the top down feature map, it tries to identify the small object. Okay, a fine-grained object. Okay, then the one in the middle is trying to predict the object with the medium size. So well, actually you can call it still use 3 scales, right? Okay, but it doesn't have to figure out what should be the anchor box. Okay, you need to try out 3 scales, but somehow it still needs some. It still will use some anchor box. Okay, you will see that later. Okay, so this about the feature pyramid network. Any question? Okay, it's quite easy to understand, right? Okay, 金字塔 ，OK 从大到小，然后从小到大 ，OK， 就这样。然后这边是做加化直接相加。我有写在这里它做 element. I didn't put it pixel-wise because when I say element, because the addition is carried out from the feature map. Okay, from the feature map. So each point in the feature map we call the element. Okay, so it's so-called element-wise addition. But some do replace addition with concatenation. Okay. Okay, so that's it. Okay, then you can go through the detail yourself. Okay. Prediction. I put a note here. Okay. Before you do the final prediction for the class and the bounding box, you still go through a 3x3 convolution layer. Okay. 3x3 convolution layer. Okay. Okay. So, but when you do the prediction, okay, when you do the prediction, it still carry out the regional proposed network, okay, it still carry out, okay, but a more simplified version, just like fast RCN. 它这个做完以后，在每一层呢，它还是有在做这个 region proposal network 去找它 ，okay, to find the bounding box, okay, to find the bounding box. Okay. Oh, it's easy because in the lower scale, you take each element as an anchor center. Then you try out different boxes, okay, and then do your final prediction. That's it. Okay, that's the only thing it did. Okay. So anyway, you still have to rely on region proposal. So it's still a 2-stage approach for object detection. 它还是要2个阶段。Okay. Okay. So we already talked about the regional proposed network, right? When we talk, when we mention fast RCN. So now something you have learned here is the feature pyramid network. Okay. Okay. So anyway, this is the basic architecture. Okay. Still based on residual net. Okay. Bottom up. Then top down. Okay. Feature pyramid. Okay. Then and then one you predict the class and bounding box. The other one based on the feature, and also you need the information about the bounding box. Then you go through 40 connected layers. Okay, 40 convolutional layer. Okay, FCN for mask. Okay, for segmentation. Okay, so that's it. That's the basic idea. Okay, for the mask RCN. Okay. And also, in the mask RCN, it does not use ROI pooling. It uses ROI align, okay, align, because when you try to find the region or the anchor box, okay, from I think this is much easier to understand. From here, when you try to find it, you need to align, okay? You need to align the possible anchor position. And then you can refine its bounding box based on the prediction or regression model, okay? So here, it uses a little bit complicated. I will skip that, okay? I don't have the time. But I give you all the required information. Align, it means do the alignment. 它会去修正 ，OK。ROI means region of interest， OK， 有兴趣的区域的调整项 ，OK， 怎么调整？Because every time you reduce by 2, okay, when you reduce the size, then if the original bounding box here, when you come to here, the corresponding bounding box, the location may not be integer. They are not integer, okay? But you need to do something, okay? That's so-called ROI align, okay? Here. I will show you later on here, okay? But anyway, that's the purpose for that, okay? Then the final loss function contains 3 terms. The very first L means the loss function. First, you calculate the classification loss, okay? 分类的损失. Then LOC means location, the bounding box, okay? The loss. And finally is the mask, the segmentation loss. You put all 3 terms together to determine all the required parameter, which are the filter you're going to learn, okay? So you include the classification, loss, location, loss, okay, and the mask or the segmentation loss, okay? Here, the mask loss, okay, is simply given by what? The class entropy, okay? Now, read it like this. Yij is the ground truth, okay? For the level, the right class, okay? The value is either 0 or 1, okay? For some class. Then you have a Ykij. K is the class it predicts, okay? By the I still prefer to talk about this one, okay? It's much easier. Okay, you will make the prediction, right? You will make the prediction about the class, okay? If K, then and then okay. M is the size of the mask output. Okay, the mask. Well, actually, it is specially determined by the bounding box, right? Okay. So Yij is the ground truth. The value is either 0 or 1. 1 is the pixel value, okay, for the target object. Okay. YKij is the case. K is the class that you predict, that the model predict. Okay, and Ij is the corresponding, right? Okay. So that's it. Okay. So it's based on binary cross entropy. Okay, for the mask. Then you need to do this for each class. Okay, for each class. Okay. So that's the mask prediction that you make. Okay. So this is the final just figure compare what the architecture or the main difference between RCN, fast RCN, faster RCN, and the mass RCN. Okay, so let's see. Okay, so okay, just give you some more detailed information. That's it. Okay, everything just repeat what I just mentioned here. Okay. And also, I just mentioned here's an updated version of mass RCN called point range. Okay, called point range. Okay, it uses a more fine-grained feature. Okay, it will give the basic estimation. Okay, of the mask. And then you will do some more detailed point-wise estimation and put them all together and go through an MLP, okay, multi-layer perceptron, to refine the segment region, okay, just like, oops, I didn't show you, okay, that's it, okay. I wish the information should be included somewhere in the end of the material, but we don't have the time to mention a lot. But anyway, if you want to use a master RCN, then you might look for the point rank. Okay, as I mentioned, the code has been released, okay, last year, so you can use it for mass RCN. Okay. Okay, so any question about the RCN-based model so far? Anything? Okay, if not, now let's talk about YOLO. Okay, why say you only look once? Because it does not need the proposal. It does not require region proposal, which means it's a one-state object detection. Does not like any RCN-based model. First, you need to find the proposal, right? Region proposal, and then from each proposal, try to identify the possible bounding box. But for YOLO-based model, it identifies. Okay, it does not require to find the proposal, which means it can be very fast, okay, compared with the two-stage method, okay? Here's how it goes, and you will be surprised that it works, okay? It divides the input image into an X by X grid. That's it, okay? I didn't mean it's done, but that's the idea. What? I'm too slow. It's 2 o'clock. And anyway, can you see the grid here? Okay, we have an input image. Then first we divide it into the grid. Okay, each one is called a grid. 好，几个那个格子。That's it. Then you will try to identify the bounding box for each grid. That's it. So that it does not have to look for the proposals, but it checks for each grid. Now, the accuracy will depend on how many grids, right? It is x by x, so we have an x horizontally and x vertical. That's it. Okay, that's how we define it. And for this case, this is the grid, right? This yellow frame here. Now, from the center, eventually you find there's a bounding box. This is the final bound. The blue line here is the bounding box. Then this is the center of the bounding box. And anyway, the center, it falls within the yellow grid. Okay, that's the idea. And I show you how you do it, how you find the bounding box. But anyway, that's is one step. Okay, algorithm for object detection. But anyway, you need to check every possible grid. I mean, compared with ASEAN, it's fast. It's fast because it didn't have to use any way to find a possible proposal. But anyway, it just checked. But it didn't check it pixel by pixel, but it checked it grid by grid. Okay, 每一个格子它都要检查。But for each grid, it still need anchors, buttons. Okay, but it does not have to specify the possible sizes because the sizes is given by a feature pyramid network. Right? Remember, we use 3 levels, okay, to identify a small object, medium-sized object, and very large-sized object. Okay, so for each feature map, then we will carry out this operation. Okay, to find the possible bounding box. Okay, let's take a break. Okay. Anyway, today I will finish object detection. If I have the time, then we will go for the GN. Otherwise, next week, I think we will be enough to talk about the basic idea about GN, okay, and cycle GN and pixel to pixel. That's for image to image translation. 影像到影像的转换 okay, to transfer black and white to color image, or transfer, okay, and from an image to another image. That is different from semantic segmentation. Okay, now for just one image, a picture to a painting, for example. No, okay, we can use the GN. Okay, then anyway, let's take a break. If I have enough time, I'll mention this is Euro 3. Okay, then I'll talk about Euro 4 and Euro 7. Okay, then that will be enough. Even up to date, there's a Euro 8. But I don't think you need all the Euros. Okay, just pick one. I mean, the difference basically is minor. It's not that significant. Okay, anyway, let's take a break.